Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in today's class, what we are going to discuss is the ray diagrams regarding the convex mirror. Okay, in the previous class, we have discussed about the ray diagrams of the concave mirror. We have drawn a few of the diagrams, and I think the other diagrams are now easy for you to understand, so I think you can easily understand and draw it from the book. If you have any problem, you can mention it in the comment box. We can also do another class regarding those diagrams. Okay, so today we are going to see the image formation in a convex mirror. Convex mirror. Okay, so basically in convex mirror, in convex mirror, what is the convex mirror like? In convex mirror, we know that for a convex mirror, the inner surface is silver while the outer surface acts as the reflecting surface. So if we, in this case, if we just take the inner surface as silver, then the outer surface acting as the reflecting surface, and hence this is the diagram for a convex mirror. Now, for a convex mirror, there are definitely center of curvature and focus, but it will be actually on the inner side of the mirror. Okay, so say if this is the focus of the convex mirror, then double the length here, almost here it will be the center of the curvature. Now, for this kind of mirror, you keep the object at any point, the image formation is of the same kind. So we can take the object anywhere in front of the convex mirror, we will get the same kind of image. Let us see, if I consider an object placed at this point, it may be any distance from the mirror. Okay, now we have to take at least two rays. So let us take one ray which is coming, which is incident parallel to the principal axis. So like this, it is incident parallel to the principal axis. Okay, then we know that the ray which is incident parallel to the principal axis, what happens? That ray gets reflected in such a way that it either passes through the focus in case of concave mirror. In case of convex mirror, it appears as if it has been coming from the focus, or appears to be passing through the focus if it is traced back. We can say it like this. So for this particular case, you can see that the reflected ray will be something like this. Okay, if you consider the reflected ray, that see, it appears as if it has been passing, or it has been coming out from the focal point. Or you can also think like this, that if the reflected ray is traced back, it will meet at the focus in virtual position, okay, in virtual situation. So this is the ray. Another ray that we take is the ray passing the center of curvature, and as you know, the ray which passes to the center of curvature, that ray actually traces back its own path. So incident ray and reflected ray have the same path. So consider the second ray like this. So we have to join this point and the center of curvature. So it's something like this. Just join. Okay, so it will be something like this. So this is the incident ray and this is the reflected ray itself. So the reflected ray goes out like this, something like this. Okay, so this is the diagram. Fine. Now you see the dotted lines meet at a certain point, and this point is the image. This point is the image. Okay, as it's a virtual image, we are not drawing it by solid line, rather we are drawing it by dotted lines to indicate that it is a virtual image. So this is how the image for a convex mirror is formed. And as you can see, if you consider the nature of the image, first of all, the image is virtual in nature. Second is that as it is virtual, it is upright or erect. Second point is upright. Okay, and third point is that it is diminished. You might be wondering, if we change the position of the object should it come in different? You can draw the ray diagram for various positions. You will see that the image that we are taking, it's having the same nature overall at all the places. So this is the diagram for a image formation for a convex mirror. Okay, so I hope the ray diagrams for the different two kinds of mirror, convex and concave, for different positions of the objects is clear to all of you. Okay. So now let us, as we have already discussed, have we discussed the sign conventions? Okay. So today we will be, after this we will be doing some of the numerical problems, but before doing those numerical problems, I think it is important that we must remember the sign conventions, and I hope the sign conventions are clear. Okay. So what are the sign conventions? Just a recapitulation about the sign conventions. Okay. So as we know, in case of, so just we are sign conventions recapitulating. Okay. So for a concave and convex mirror, what are the sign conventions? Let us just go through it once again quickly. Okay. First of all, if I consider the focal length, okay, f, the focal length for a concave mirror, is actually negative. Okay. So the focal length for a concave mirror, okay, let us write this in the middle. It will be easier to compare. Okay, so this is a chart. So for a focal length for the concave mirror, the focal length is negative, whereas for convex mirror it is positive. Okay. Next, what about the object distance? The object distance is denoted by the letter U. Object distance for both concave and convex mirror will be always negative. Remember this. It will be always negative. Okay. Next is the object height, denoted by the letter H subscript O or simply O. Object height. Now object height is always positive, irrespective of the convex or concave mirror object height. Now what about the image height and the image distance? Okay, so for that we will be considering the kind of image. As you know, for if we consider a real image, okay, so for a real image, what happens? The image is always inverted. So the image height hi or simply I is always negative, and the image distance, that means letter V, is always positive. Sorry, it should be negative. Okay, is always negative. Whereas if we consider a virtual image, in that case, the image height is always positive, as it is upright or erect, and the image distance is also positive. So remember this sign conventions, it will be helpful in solving the numerical problems. Okay. Oh, sorry, the lower portion has been cut out. Let me just lower the camera. Now it's visible. Yes. Okay. Fine. So these are the conventions that must be kept in mind while we are solving the numerical problems. Okay. Fine. Okay. So today is a short lecture. In the next video, we will be actually doing some of the numerical problems we are not doing in this class. Okay. So the next video will be very quickly updated. If you have any query or any question regarding this portion up to which it has been taught, please do mention it in the comment box. We'll be happy to solve the problem. Okay, so please wait till the next video. Till then, please do study well. Thank you. Goodbye.